Our preparations for testing the Turborocket Mark 6 unit continue. Here I'm going to show you some of our measurements that we make on the system. As shown previously, our Turborocket Mark 6 unit has been installed, and we're doing the instrumentation hookups on the system, getting it ready for the measurements that we need to make on the system. One of the measurements that we need to make is the measurement of our airflow rate to the system. So the propellants that we're going to use for this particular testing, due to their logistical ease, are going to be alcohol, ethanol alcohol basically, and gaseous air. And so the air supply to the Turborocket unit will come from just a standard air supply system. We're just doing a test flow here. It doesn't take a lot, about a handful of standard cubic feet per minute. And it flows into the system through our check valve, or our control valve here, which will power up. But I wanted to show you how we measure the flow rate of that air system through our lines and into the Turborocket engine. What we're using is a volumetric flow meter from Orange Research. This is an interesting gauge type meter. I haven't used this type before. I've used rotometer types, kind of like that guy. But I was interested in trying out this particular meter, and got some good response from the Orange Research guys, and I'm happy with this gauge so far, and we'll see how it works. Basically, the air supply comes in through this line. We want to measure the upstream pressure, and then we'll measure the standard cubic feet per minute of the airflow going through this system, and we'll scale it from the pressure that we read here relative to the design point scale of 100 psig through some conversion factors, and that gives us the correct standard cubic feet per minute going through the system. It comes out, we have a control valve here, and then this goes down to our air supply system and our solenoid valve, our shutoff valve here. So let's turn our solenoid valve on. So we'll just power up the old system here. Power that on, and then you'll hear the snap of the solenoid here as we activate that system. So now our solenoid valve is open. You can see it clicking there. So that's that unit. Okay, so let's give it a little air. We'll goose up our regulator supply here. Yeah, we'll run it up to a few hundred psig, and you'll see it coming up on our gauge there. Let's run it up to about 80 psig on our supply pressure, and we'll have something equivalent here on our supply pressure here. Now we'll start cracking open this valve, and you'll see the flow going through the system. We want to achieve about 11 standard cubic feet a minute of airflow through this system, and scaled for the supply pressure that we get, we end up needing about a little more than that, about 12 or 12 and a half on this gauge to account for the pressure under 100 psig here. So typically in these types of flow systems, by the way, you can control the supply pressure or the flow rate if you only have one valve, but we have kind of two. And if you have two, then you can control simultaneously the flow rate and the supply pressure. So our control valve on the upstream side is the regulator, and then this is our control valve on the downstream side. Okay, so let's start cranking this open. You'll see the flow start going. Okay, so let's run it up to about 12 standard cubic feet a minute. And at the supply pressure of a little under 40 psig, we can back calculate the corrected standard cubic feet per minute, and it's going to be less than 12. It'll be some scale factor down from that. But you can see our system is flowing there, and the flow is coming out the front of the nozzle as we would anticipate. And so that's going to give us, with the correct supply pressure and valve setting here, that'll give us the correct flow rate through the system. So that's how that system works. You can also see that we can shut off the system by shutting off the solenoid valve. So that's how we can control that, and then we can also adjust the flow rate through this ball valve here. So that's our supply system, and that's how we're going to measure the airflow through the system which is our oxidizer supply, effectively.